Hello everyone, I am Purvaja Rao from TEENTC. Today I will be presenting a topic on Internet of Things based on patient's health monitoring system using wearable biometric device as a presentation for employability skills and mini project. And this is the outline of today's presentation. Introduction. What is IoT? Internet of Things IoT is a combination of hardware and software technology that produces trillions of data through connecting multiple devices and sensors with the cloud and making sense of the data with intelligent tools. Internet of Things has brought revolutionary changes in information and communication technology. As we all know, it gives access to vast data and it allows devices embedded with sensors and connects with the actuator to communicate and exchange information and data through internet. Now, why we use IoT? Why we need IoT? IoT creates huge opportunities as physical world is integrated into computer-based systems. This integration results in a reduced human participation, improved efficiency along with the economic benefits and accuracy. IoT for healthcare. Keeping patient at close observation and monitoring critical signs such as heart rate, blood pressure, and body temperature is a major significant phenomena in healthcare monitoring systems. Majority of the monitoring devices are available at critical or intensive care units and operating rooms. But these devices show measured values at the adjacent display only. It is quite possible that the doctor has not been alerted at emergency situations when the patient's condition come down to critical stage in spite of 24-hour close observation. Also, after getting discharged from hospital and taken to home, a patient needs to be kept close observation and report any head injury to doctor too. Using IoT as technology combining doctors and patients, it is possible to keep a record of patient's health status. This will help the doctor to understand that the patient more accurately. Let us move on to the proposed methodology we used in this to create this project. The system consists of two different sites where one is the web application site consisting of web pages including database and another is the patient side where consists of variable sensor. The above block diagram shows the block diagram of this project. The web pages are created with HTML and CSS and JavaScript, and for the database, SQLite has been used. Flask integrated with SQLite database to store patients' health condition that can be used later. Web server provides an authentication for doctors and patients. Doctors are able to see multiple patients' data at a time and are able to check the whole condition of an individual patient from using the internet. We used microcontroller as Arduino, GSM, and Wi-Fi for this project. Critical level is also pointed out in this website. Let us move on to hardware requirements. First comes Arduino. In this paper, different instruments and technologies have been used for achieving better output. For example, like Arduino Nano is a very small development board which supports Atmega 328 microcontroller. Nano has 14 digits I/O pin, among which PWM output is provided by 6 pins. It also has 8 analog input pins. Nano's clock speed is 16 MHz. Besides, it has an operating voltage of 5 volts at a logical level and recommended input voltage is 7 to 12 volts. We used Raspberry Pi. In this paper, Raspberry Pi 3 Model B as a server and database. This is a small computer with 1.4 gigahertz quad-core processors, 64-bit. It uses wireless LAN dual band, a Bluetooth module of 4.2. Moreover, it also has a 1 GB RAM and 40 extended GPIO pins, 4 USB 2.0 ports, and 4 pole stereo output ports. Temperature sensor LM35. It is a temperature sensing device that senses temperature and gives a voltage output nearly proportional to Celsius temperature. It has a range of minus 55 degree to 150 degrees, and its scale factor is 10 millivolt per degree Celsius. Next, GSM SIM 900D. SIM 900 is a module which uses quad band 850 900 and dual band 900 and 1900 GSM GPRS module. It communicates with controller through 80 commands. It consumes very low power. At sleep mode, it consumes 1.5 ampere and it operates soundly between minus 40 degrees Celsius to plus 45-degree temperature. Piezoelectric sensor. Piezoelectric sensor is a device which converts pressure and temperature or force to electric charge. The change is electrical charge across the sensor due to blood flow in artery and veins is calculated by the microcontroller to determine human rate. This is the system implementation. We simulated this on Proteus. For wearable device, this circuit was made. Arduino microcontroller was used for wearable device part. Here, it is said that two sensors, one for body temperature and another for reading heart rate. Two sensors taking multiple data to take best possible measurement. Piezo sensors is used for heart rate measurement, and good thing is that it can be used as a patch. Piezo sensor data is in analog form and which is amplified and converted to digital signal from the microcontroller to process. LM35 it gives continuous body temperature of the patient. The temperature sensor is placed below the device for best result as in direct contact with the patient. Arduino fetches the data from the sensors and sends it to server with the help of SIM 900 DGSM module every 10 minutes. In the time of critical situation, Arduino sends SMS through GSM SIM 900D to emergency contact and also give alarm signal. Now, let us discuss the results and the discussion. As you can see above, the web page accesses the username and password of the patient and it logs down the real time data of the patient. It logs down the body temperature as well as the heartbeat. As you can see above, it logs the data of the patient with respect to date and time, as well as the temperature and the heart rate. And the graph above shows the difference in the heart rate per minute. This is the SMS that is sent by the GSM module when the patient is in critical condition. Conclusion. The problem of insufficient doctors can be solved perfectly. This project uses low power consumption. It has a simple built-in architecture and is easy to implement and henceforth cost effective. It is accessible everywhere by the internet. Future scope. In this project, the heart rate sensor that is used is quite unstable, and hence future scope is to update and make a stable heart rate sensor. Blood pressure and ECG and EEG can be implemented as well. Advanced database security can be implemented so as to protect the patient's data. A video conferencing system can be used in places like rural areas to help the patients. These are the references that was used in this project. Thank you so much for listening. I hope you have a good day.